This is the practice test for Unit 8 on sequences. Again, we want to make sure we show all our work and circle the answers so everybody knows we know what we're doing. At the top here, I've got something a little bit different. Because this is so formula-based in this section, or in this unit, let's write down what the nth term formula is for each one of these. So for an arithmetic one, and again, I don't like just saying the parts of the formula. I just like reciting where this came from. So the nth term is going to be the first term plus n minus 1 common differences. It reminds us that what's going on here is we're adding that common difference each time, so that's why we use the d. And then the format for the geometric ones is very similar. So this is going to be a sub n. So the nth one is the first one times n minus 1 common ratios. So again, the way we show that ratio gets repeatedly multiplied is we have the exponent of -1. All right, so in this first part it says determine the type of sequence, list the next two terms, and then write the explicit and recursive formulas. So we need to do each one of those things. I'll lower this so we can kind of see what those formulas are again. So it says, let's see, determine the type of sequence and list the next couple. Well, let's go ahead and list a few of these and then figure out which type it is. So we've got 19, then 11, and then 3. So remember, to find a common difference, we can take any one and subtract the one before it. So if I did 11 minus 19, I get -8. And if I did 3 minus 11, I get -8. If I wanted to find a common ratio, I'd just do division. But as long as those two are the same, we've identified what the common difference is. So the common difference here is -8. That means every single time that we're adding a -8, or you could think of it as subtracting 8. So 3 minus 8, that would be -5. And then -5 minus 13, that's going to be -5 minus 8, that would be -13. I'm thinking ahead of what the answer is here. Okay, so this is definitely arithmetic, and then we want to write down an explicit formula. So the nth term is going to be the first term of 19 plus n minus 1 common differences, and the common difference in this case is -8. So we're going to go through and we're going to distribute and then simplify. So this is going to be 19 minus 8n, and then this would be plus 8 when we multiply there. And then we've got a couple of like terms. So the explicit formula looks like this. A sub n is equal to, we're going to do -8n because we like writing that variable term first, and then we put the two of those together and we get plus 27. So that right there is the answer for the explicit formula. Now, recursive ones, we have to give it a place to start. So we tell it what the first one is. So the first one's 19, and then we say how we get to the next one. So to get to the next one, we take the one right before it, the previous one, and then we add the common difference. The common difference in this case is -8, so I'm just going to write -8. So there we go. We've got our starting place, a sub 1, and then we've got this formula that tells us how to go from the previous term to get to the next term. In this case, we just subtract 8. So let's take a look at this one. We've got some fractions here, so this doesn't look like very much fun. Let's see if we can figure this out. Let's find the pattern here. So it looks like the denominators just continue to stay 4s. And then we've got a -3, then a -1, and then a 1. So what's happening here is we're going up by 2 every single time. So if I add 2, that would be a 3, and if I add another 2, that would be a 5. So we've got 3/4 and 5/4. Now, if you think about it, what's going to happen here is we're adding 2 to the numerator. So that's a 2 on the top and a 4 on the bottom. Here's our common difference. Our common difference is 1/2. So this is definitely arithmetic, and let's come up with the formula. So the formula is for the nth term is going to be the first term, which is -3/4, and then plus n minus 1 common differences of 1/2. Now, this might not be thrilling, but we can handle this. Let's go ahead and distribute through. So this is -3/4, and then plus 1/2 n, and then -1 times 1/2 would be -1/2. So the nth term formula, or the explicit formula here, is going to be 1/2 n, and then we need to put the two of these together. Well, this would be -3/4, and I'm going to get a common denominator of 4. Remember, it's that 2/4 here. So this would be -5/4. Okay, so there's our nth term formula, our explicit formula right there. And then our recursive one, again, recursive ones are a pain in the butt to work with, but they're actually pretty easy to write. So the first term is -3/4, and then the next term would be the previous term, so we'll do a sub n minus 1, and then we add the common difference, which is 1/2 in this case. All right, so there we go. There's the first term and the recursion formula. Let's take a look at this one. We've got a 3, then we've got a 21, and then a 147. Well, you can tell this is not going to be a common difference. This is not going to be arithmetic, because to go from 3 to 21, if you just added, you'd add 18, and then we've got to add a lot more than 18. Let's see what 21 divided by 3 is. That's a 7, so we times by 7 there. And then what's 147 divided by 21? Now, if we need to grab a calculator, we will. So I'm going to clear this off. 147 divided by 21, we end up with 7. So we do have a common ratio here. So R on this one is 7. So let's see what we get if we were to continue multiplying by 7. So I'm going to shrink this down just a tad here. So we're going to take that last term of 147. We're going to do 147, and we're going to times by 7. So we get 1029. So we'll do 1029 here. And then I need to multiply that one by 7 to get the next one in line. So 7203. So 7203. Again, this is geometric because of that common ratio. And then let's figure out what this is here. So this is going to be a sub n is equal to, the first one, 3. Common ratio is 7 raised to the n minus 1. So let's write this out as 3. And then this would be 7 to the n, and then 7 to the negative 1. And remember what happens with this negative exponent. It means reciprocal. So I'm going to trade this off for a 1/7 out front times 3 times 7 to the n. And then we can just multiply these together. That would put a 3 on the top and a 7 on the bottom. So that means the nth term formula, the explicit formula, is going to be 3/7 and then 7 raised to the n. So there's that guy right there. And then the recursive one, we just write down what the first one is. The first one's 3. And then to get to the next one, we just take that common ratio of 7 and we multiply it by the one right before it. So a sub n minus 1. Again, that's the next term. This is the previous term. And there we go right there. Okay, let's take a look at this one right here. Let's see. We've got a 1, then we've got a 2/3, then we've got a 4/9. Let's see. If I were to take 2/3 and divide it by the one right before it, that would be 2/3. And if I took 4/9 and I divide it by the one before it is 2/3. Let's see, I flip that over and I multiply, so that's going to be 3/2. I can cancel the 3 with the 9, so that's a 3, and the 2 with the 4, so that's a 2. So again, I get 2/3. So here's our common ratio. Our common ratio is 2/3. Now, I'm going to leave that right there, but we've got to figure out what these next two terms are. So let's see if we can figure this out a couple different ways. I'm going to put this over a 1, and I want you to notice what's happening in the denominator. We've got a 1, then a 3, then a 9. So what's happening here is we're multiplying by 3 every time. So this next one's going to be a 27, and then we multiply by 3 again, and we end up with 81. And then let's see on the top where we've got a 1, then a 2, then a 4. So we're doubling every time here. So this is going to be an 8, and then this is going to be a 16. So we've got the terms right there. And that should kind of make sense because what's going on here is every single time we're multiplying the top by 2 and we're multiplying the bottom by 3. So now we need to figure out an explicit formula for that one. So I'm going to make this one bigger for the time being. If we have to come back, we'll do that. So let me slide down here. And let's see what we've got here. So this would be a sub n equals, first term is 1, and then we're taking the common ratio of 2/3 and we're raising that to the n minus 1, and then we do some simplification. So the 1 is not going to matter at all, so I'm not going to write that again. I'm just going to write 2/3 raised to the n, and then I'm going to write 2/3 raised to the negative 1. And remember the cool thing about this, the negative means reciprocal, so literally we can just do the reciprocal of this right here. So that's going to be 3/2, and if I raise that to the first power here, it would just still be 3/2. And then we're going to do 2/3 raised to the n. So here's our formula. A sub n is equal to 3/2, and then 2/3 raised to the n. So there's our explicit formula there. Now we're going to write down the recursive one. Whoops, the recursive one starts off with a 1, and then to get to the next term, we take the common ratio of 2/3 and we multiply it by the previous term. So there's our formula right there for the recursively defined one. Now, if you did want to check anything, if we wanted to plug into the calculator and see if, gosh, is that 1, 2, 3, 4, is the fifth term 16/81st? We could plug this in. So just for the heck of it, let's go ahead and plug this in. So I'm going to do a 2/3. So this is going to be alpha y equals, 3 halves. 3 halves. Okay, and then we're going to close the parentheses. Guess I didn't really need parentheses on that one. And then we're going to do, let's see, 2/3. 2/3, close the parentheses, and then we're going to raise that to, if I want the fifth term to get that 16/81st, the fifth term, I plug in a 5. So I'm going to put a 5 right here, hop down here, and make sure that that looks good. And lo and behold, look what it gives me, 16/81st. So we are all set. Okay, all right, let's slide down here and take a look at these next couple. On this, it just asks for an nth term formula and then find the indicated term of the sequence. The nice thing about this one is it tells us that this is arithmetic because it says that d is equal to 8. So let's find an nth term formula. And notice that they just say a is equal to 4. Remember, we can assume that that's a 1 there. So that means that a sub n is going to be the first term plus n minus 1 common differences. So common difference is 8. So we'll distribute through. So we get 4 plus 8n minus 8. So that means the nth term formula is going to be 8n minus 4. So we'll go ahead and circle that one. We've got the nth term formula. And now we want the 13th one. So this is going to be 8, and we're going to plug the index in here, and then we're going to subtract 4. So let me grab the calculator for that one just to make sure. So we're going to do 8 times 13, and then we're going to subtract 4. We end up with 100, okay? So a sub 13 is equal to 100. So the 13th term is equal to 100. All right, next one. This is the first term, 2700. Tells us this has a common ratio, so it's geometric. And then we want to find the 7th term. Okay, so let's see what we've got here. So the nth term would be the first term, 2700, times the n minus 1 common ratios. So this would be 2700, and then this would be 1/3 to the n, and then 1/3 to the -1. And remember, this is going to be the reciprocal. So the reciprocal of that is going to be 3. So I'm going to cross this off and bring a 3 out here. So here's what we end up with. 3 times 2700, we'll double check here. So let me clear that off. 3 times 2700. 3 times 2700 is 8100. So this is going to be 8100, and then we're going to do 1/3 raised to the n. So here's our nth term formula, our explicit formula, and we want to find the 7th term. So to find the 7th term, we're going to do 8100, and then we'll do 1/3 raised to the 7th. Now, I'm going to do something a little bit different. I'm going to do 8100, 8100, and then in parentheses, I'm going to do 1 divided by 3. So I'm putting this in as a division problem, and then I'm going to raise that to the 7th. What that's going to do is it's going to calculate this as a decimal, but I want to just remind you how this works. So I think I've got this typed in the right way. We go ahead and hit enter, and it gives us this. Now, that doesn't look, well, hang on a second, maybe that does look like a repeating decimal. So let's see if the calculator can actually change this into a fraction. So let's take that answer, change it into a fraction, and we end up with 100/27. So a sub 7 is equal to 100/27. Now, that actually looks a little bit better than this ugly decimal that we had right here. So this is actually probably the best way to write it. So I'm not going to write down whatever that is approximately. So let me go ahead and erase that there. Okay, let's take a look at this one right here. Number 7, we want to find the 10th term if we've got a 12, then a -36, then a 108. Now, it's true, you could just kind of figure out what's going on here and write out all 10 of them, but we do want to use all these skills and practice these skills. So let's take a look here. To go from 12 to -36, gosh, we'd have to subtract 48 if this was a common difference, and then there's no way the difference between the two of these is 48. So this is definitely going to be geometric, and let's just double check. Take any term and divide by the one before it. So that's going to be a -3. Let's take 108 and divide by -36. Get a little calculator help on that one. So 108 divided by -36, we get -3. Okay, so the common ratio on this one is -3. So we're going to write down a sub n is the first one 12, and then negative 3 raised to the n minus 1. It's n minus 1 common ratios here. So let's look at the simplification process on this. So this is going to be to the n, and then this is going to be negative 3 to the negative 1. So we just do the reciprocal of this. So I'm going to cross this off, and we're going to do the reciprocal of negative 3, which is negative 1/3. So I'm going to do a little bit of canceling here. So here's what we end up with. A sub n is equal to a negative times a positive would be negative. And then we cancel these, that's a 4, or in other words, 12 divided by 3 is 4. So negative 4, and then we've got negative 3 raised to the n. So here's our nth term formula, and then we want to find the 10th one. So a sub 10 would be negative 4, and then negative 3 raised to the 10th. We'll grab the calculator for that. So negative 4, and then parentheses negative 3, raise that to the 10th, hop out on the very end, hit enter, and we get, oh, that's pretty big, 236, 169, 196. So a sub 10 is negative 236, 196. Did I get that right? Yeah, 236, 196. Okay, let me move that over so that looks a little bit better. Okay, so this is the answer right here. Now, one thing we can do to kind of double check and make sure that we got it right, we go from positive to negative to positive. The next one would be negative. That means the first one, the second one, the third one. So all of the even ones should be negative, and this does work out to be negative. So we're in good shape there. Okay, let's take a look at this one right here. Some big numbers on this one. 232, then 188. Okay, so if we thought this might be geometric, we'd take 188 and we'd divide by 232. So let me grab the calculator. We're going to take 188 and divide by 232. We get that decimal, and then we try 144 divided by 188. So 144 divided by 188. We don't get the same thing, so there's no way that this is geometric. We don't have a common ratio here. So let's go ahead and do a little bit of subtraction here. Let's take 188 and let's subtract 232, and then let's take 144 and subtract 188. So let's see here. What do we got here? 188 minus 232. So that's negative 44. And gosh, that's going to work out to be negative 44 also. So the common difference here is negative 44. All right, so let's go ahead and come up with a formula on this one. So this is going to be a sub n is the first term, 232, plus n minus 1 common differences. Common difference is negative 44, so I'm going to put that in parentheses, and then we got some ugly distributing to do here. So 232 plus, or that's going to be a minus, because when we multiply the negative 44 through, negative 44n, and then plus 44. Okay, so we've got 232 plus 44. We get 276. So here's our nth term formula. So negative 44n plus 276. 276. So there's our formula right there. And they want the 73rd term. So we're going to plug in a 73. So negative 44 times 73 plus 276. So some big numbers, definitely relying on a calculator here. So negative 44 times 73 plus 276. And we get negative 2936. So a sub 73, the 73rd term, is negative 2936. So we'll go ahead and circle that. I'm going to pull this up, just make sure. Yep, I got that right. Okay. All right, let's take a look at the last couple on here. Once we get to this point and we remember how these work, if we've got a table, we can actually make coming up with these formulas a little bit easier. So it says determine the type of sequence and write an explicit and recursive formula. So on this one, you'll notice that the first term is 5, the second one is negative 1, then negative 7, then negative 13. So notice what's happening here. We went from 5 to negative 1, so if you subtracted 6 each time, we'd have our little formula right there. So that means the common difference is negative 6. But remember, if you've got a table, if you can kind of back up and you can figure out what that initial value was, what that 0th term was. So if going this way we subtract 6, going the other way we'd add 6, so this would make this 11. So see if this doesn't make sense. 11 minus 6 is 5, 5 minus 6 is negative 1, negative 1 minus 6 is negative 7, and so forth. So that means we've got our 0th term, or our y-intercept, if you want to think of it that way. So that means a sub n is going to be negative 6 times n, and then we just add that initial value here of 11. Very quick, a lot less simplification there. And then the recursive formula, a sub 1. Remember, the first one is this guy right here. So this is going to be 5. And then a sub n is going to be the previous one, a sub n minus 1, and then adding whatever the common difference is. In this case, the common difference is negative 6. So there's our formula on that one. Okay, let's take a look at this one. If this one was arithmetic, we could probably take a bet that this one's going to be geometric, and you can kind of see that it's got to be. There's no way that this is the same common difference between these. The difference here would be something like 6, and here it would be like 42. So there's no way we have a common difference. This one's definitely going to be geometric. Let's see if we can tell what it is. Let's take any term and divide by the one before it. So don't get caught up in this. Take negative 1 and divide by negative 7. We get a common ratio of 1/7. Common ratio of 1/7. 1 on the top and 7 on the bottom. If we did this one, negative 49 over negative 343, first of all, that's going to work out to be positive, and then I'm just going to grab the calculator here. So we're going to do negative 49 divided by negative 343. I get that ugliness right there, but remember, we can have this change it to a fraction for us, and it changes it to 1/7. So the common ratio is 1/7. Now, we're going to try and write this down in a very quick way. So the nth term, remember, would be a sub 0 times the common ratio to the n, but we don't have the 0th term. So remember what's happening here. We're multiplying by 1/7 every single time to make it get smaller and smaller and smaller. Or you could think of it as dividing by 7, negative 7, or sorry, positive 7. So let's go this way. We'd actually have to multiply by positive 7. So going this way, we multiply by 1/7. Going this way, we multiply by 7. So let's see if we can figure out what that term is. Let's grab the calculator, negative 343, and we're going to times that by 7. So we get 2401, negative 2401. So we're going to replace this with negative 2401, so negative 2401. And then we're going to replace the common ratio here with 1/7, and we're going to raise that to the n. So we think this is the formula right here. But let's just do a little bit of double checking. Let's see what happens when we plug in a 4. So that means the 4th term should be negative 2401, and then this would be 1/7 raised to the 4th. Now, if we plug that in the calculator and it gives us negative 1, then we're in business. We know we got this right. So this is negative 2401, and then in parentheses, we're going to put 1 divided by 7. Again, if it gave me a decimal and I needed to change that to a fraction, I could do that. So let's just check and make sure that we've got this in here the right way. And lo and behold, it gives us the right thing. So we've got the correct answer. And then the recursive formula, the first term, again, this one right here, that's the one we're keying off. So this is negative 343. And then to get to the next one, you take that common ratio of 1/7 and you multiply it by the previous ones. And the previous one in this case would be a sub n minus 1. All right, so there's the formula there. Let's take a look at the other side. Okay, on number 11 it says, determine the type of sequence and write a general and recursive formula. So on this one, take a look here. This one is a linear graph, so this is definitely going to be arithmetic. But in order to come up with a general formula, we need to figure out what is it changing by? What is the common difference each time? So this is a 2.5. This goes to 2, and then 1.5 and 1. So that means the common difference, which on a graph we can think of as the slope, is 1/2. But remember, it's going down, so we need to make sure that that's negative. So the common difference, or the slope here, is negative. So that means a sub n is equal to, remember, it's going to be negative 1/2 times n. And then the cool thing about this is whatever that y-intercept is, that's what we use for that initial value. Right here. So this is the general formula, and take a look what happens if we plug in a 1. We do get 2.5 because this would be negative 1/2 times 1. That'd be negative 1/2, and then plus 3. Negative 1/2 plus 3 is 2.5, so we get the right value right there. And then the recursive formula, a sub 1 is, remember, you got to grab the right one. It's the first one, so that's 2.5. So 2 and 1/2, I'm going to write that as 5/2. So 5/2 for the first one, and then the next one is going to be the previous one, and then we're going to subtract whatever that common difference is. In this case, it was 1/2. So there we go on that one. And let's take a look at this one. Again, notice the shape of the graph. So we know this has got to be geometric because it's shaped like an exponential function. The nth term formula, the general formula, is going to be whatever that initial value is. So we're going to put a 2, and then let's figure out what the common ratio is here. So we had an 8, then 4, then 2, then 1, and then it's a half. And this is even smaller than a half. It's tough to tell exactly, but probably about a fourth. So on this one, the common ratio is 1/2. So we're going to do 1/2 raised to the n. So there's our formula right here. And again, we can check and make sure that we get this right by plugging in a 1. If you plug in a 1, this would be 1/2 to the first, so that would be 1/2. And 2 times a half ends up being 1, so we've got the right value there. So again, first term, catch what that one is, that's a 1. And then we take, to get the next term, we take the common ratio of 1/2 and we multiply it by the previous term, which is a sub n minus 1. So there are formulas on that one. So these go pretty quickly on the back side. Let's take a look at number 13. It says the city of Saratoga Springs had an initial population of 500 people. The population grows by 10% each year. We want to figure out whether this is arithmetic geometric, write down the general and recursive formula, and then what's the population after 12 years. Well, let's write down what we've got here. So it has an initial population of 500. So before we start the stopwatch, there are 500 people in Saratoga Springs. And then after 1 year, if it goes up 10%, that would be 100% of the people that were there plus 10%. So that's going to be 110%. So that's going to be 1.1. So I'm going to grab the calculator. In fact, I'm going to make this a little bit smaller because I think we're going to be using the calculator a bit here. So we're going to take 500, so I'm just going to enter that, and then we're going to times that by 1.1. So that's going to be 550. So this is 550. And then I'd take that answer and times it by 1.1. So this is going to be 605. So after 2 years, the population is 605. And then if I were to do it one more time, after 3 years, it's about 666, okay? So this is definitely geometric, and the common ratio in this case is 1.1. So the general formula would be a sub n is equal to, remember, we take that initial value, not the first term in the sequence, not after 1 year, but the initial value. So that's going to be 500, and then the base is going to be 1.1 for the common ratio, and then we're going to raise that to the n. So there's our general formula on this one. In recursive, we write down what's the population after 1 year, so that's going to be 550. And then any year can be got by taking the common ratio of 1.1 and multiplying it by the year before that. So there's our recursive formula. And it says, what will the population be after 12 years? Well, after 12 years, we definitely want to use the general formula, or the nth term formula. So we're going to find a sub 12. That's going to be 500 and then 1.1 raised to the 12th. So we're going to plug this into the calculator. So 500 and then 1.1, we'll raise that to the 12th. Hop down on the bottom, take a look at that, make sure we got it in right. So we get 1569. Now 0.2, we can't have 0.2 of a person, so here's what we're going to say. We're going to say approximately 1569 people. Okay, so there's their population. Okay, approximately after 12 years from when this started. So gosh, Saratoga Springs is huge now, so that must have been a long time ago. All right, next one. Math Counts team is recruiting new members. They currently have 15 members and hope they find 3 new members each week. Well, the fact that they're going to be adding 3 new members each week, that's going to be arithmetic because the common difference is going to be 3. In fact, if we were to write this down, when they started, so currently they have 15, and then after 1 more week, that's going to be 18 because they had the 3 new members. 2 weeks, that's going to be 21. 3 weeks, that's going to be 24, and so forth. So the general formula is going to look like this. So the nth term is going to be, remember, we take that common difference, 3, we multiply it by n because that's kind of like the rate or the slope, and then we add the initial value. What did they start off with? At 0, not at 1, but at 0. So that's going to be 15. So this right here is the general formula, and if you wanted to check and make sure that this actually works, after 3 weeks they should have 24. So put a 3 right here. 3 times 3 would be 9. 9 plus 15 would be 24. So our formula works. And then again, recursive. A sub 1 would be, that's 18. Again, not at week 0, but after 1 week. and then a sub n is equal to the previous one, and then we're going to add 3 every week. So there's our recursive formula. And then it says how many weeks will it take before they have 150 members? So how many weeks will it take? So they're giving us the term, and they want us to figure out what the index is, or how many weeks it takes. So let's plug a 150 in right here. So this is going to be 150, and then this is going to be 3n plus 15. So we're going to subtract 15. So that's 135 equals 3n, and if you divide by 3, 135 divided by 3 is equal to 45. So 45, and remember that's weeks, 45 weeks. So in 45 weeks, they're going to have 150 members. All right, that sounds pretty ambitious, but there you go. Okay, let's take a look at this next part here. So on this one, the questions are a little bit different on 15 and 16. So it says complete the statement for each one of the sequences. So 338 is the blank term of 5, 8, 11, and so forth. So you'll notice that we're going up by 3 every single time. So let's write down a formula for this. So that means the nth one would be 3n, and then rather than going through that little mess, I'm going to back up one, and that would put the 0th term, the initial term, at 2. And then let's solve this right here. So this would be 338 equals 3n plus 2, so I'm going to subtract 2. So this is going to be 336 equals 3n, and we're going to divide by 3. So we'll grab the calculator and we'll do 336 divided by 3. So 336 divided by 3, which probably ought to be able to figure that out, 112. So it is the 112th term, 112th term of that sequence. Now, number 16 is going to be kind of interesting, because if you take a look at this one here, this is 3, then 6, then 12. So we definitely don't have a common difference, but what's happening here is we're timesing by 2 every single time to get to the next one. So that next one on that list would be 24. So that means we've got a common ratio, we've got a geometric sequence. So in order to write down the formula really quickly, it would be better if we kind of went backwards and found this is the first term, this is the second term, and so forth. If we found that 0th term with whatever the initial value was, well, in order to go this direction, we would divide by 2. So that's going to make this 3 halves. So I'm going to write down 3 halves, and then the common ratio of 2 raised to the n. That's going to make this a little bit easier. So let's take a look and see what we have here. 96 is the blank term of that sequence. So we're going to put a 96 right here, and then this gets a little bit interesting. We haven't done one like this, but I'm thinking we can kind of pull together all the stuff that we've learned and figure this out. Okay, we've got a variable term right here, and we've got a fraction in front of that variable term. So what I'm going to do is I'm going to multiply by the reciprocal. So I'm going to multiply this side by 2/3, and we're going to multiply this side by 2/3. So we're going to cancel there, and we'll do a little bit of cross-canceling here. That ends up being a 32, so we end up with a 64. So this is 64 equals 2 to the n. Now, there are some more sophisticated ways to solve a problem like this that you'll learn in a couple of years, but we can figure this out because we know the powers of 2 pretty well. And if we didn't, we could just grab a calculator and say, look, let me take a guess. I think that's 2 to the 4th. And it's not, so we could try 2 to the 5th. Whoops. 2 caret 5, there we go, 32, so 2 caret 6. That has to be a 6, so it's got to be the 6th term. I'll write it a little bit bigger, so 6th term, it's got to be the 6th one here. And if we were to just go through and say, look, every time I do this, I need to take that term and I need to multiply it by 2. So the first one is 3, and then I'm going to times that by 2. So here's the second one, 6. Third one's 12, fourth one's 24, fifth one is 48, sixth one is 96. So we can kind of confirm that a couple different ways. All right, let's talk about these last couple here. Number 17 says, what is a sequence? Well, a sequence is just a list of numbers. It's just a list of numbers, basically. But we're going to add something to that. We're going to say that it comes in a specific order. So it's a list of numbers that has a specific order. Okay, so you've got the first one, the second one, the third one, and so forth. You can't really mix them up like that. And then it says, how can you tell if a sequence is arithmetic or geometric? Remember, if it's arithmetic, it has a common difference, and if it's geometric, it has a common ratio. And then we could state a little bit further what that means. This means that we add to get to next term. So we add to get to the next term, and on a common ratio, we multiply to get to the next term. Oops, next term. There we go. Next term here. Okay. All right, so again, with arithmetic, it's better to think of this as adding rather than thinking of it as subtracting. And then same with common ratios with geometric. It's better to think of it as multiplying rather than dividing, even though there are times where it would be okay to think of it that way. And then it says on number 19, what are the two other names for an explicit formula? Well, that would be Nth Term Formula. And the other one we can call it a general formula. Either one there is fine. And then the last four, they just want you to circle the answer. And it might be helpful to read the entire question, all four of them, before you answer, because they are kind of similar. It says linear and exponential functions are continuous or discrete. Arithmetic and geometric sequences are continuous or discrete. And then we start talking about arithmetic comes from linear exponential and geometric comes from linear exponential. So here the difference in these two questions is it's talking about functions versus sequences. Remember, functions actually cover all those values. They've got a domain that includes anything. So those would be continuous, whereas sequences, those are only valid when we plug in a 1 for the first term, 2 for the second term, and so forth. So that's automatically going to make it discrete. It's going to jump from one value to the next. And then arithmetic sequences, again, they come from linear functions, and geometric, they come from exponential. Okay, so there's the practice test. I'm hoping the test is a little bit easier, but do be ready for anything. A lot of good skills here. Good luck on the test.